Welcome back, everybody. In this video, we're going to take a look at Emgu CV. For those not familiar with Emgu CV, Emgu CV is essentially a huge set of wrapper functions that allows calling OpenCV functions from a Visual Studio Windows Forms program. This is necessary because Visual Studio/.NET is an interpreted environment that cannot directly call functions written in native C and C++. Emgu is free and open source, and we can use C# to make a nice graphical front end. Let's get started. Alrighty, so to get started today, let's download C# 2010 Express. And we can find that easily on the Microsoft site. Go ahead and download from this link here, and when you do the install, you can choose all the defaults. That'll work out just great for you. Alrighty, so now we've downloaded and installed C# 2010 Express. Now let's download the latest version of Emgu CV. And we can go on the main Emgu page here, download an installation, and then follow this link to the file server on the SourceForge page. And let's go ahead and get the latest version, 2.4.0. And even though we'll be using a 64-bit computer today, the 32-bit version still seems to work great, and it's a little bit more stable and tested than the 64-bit version. So let's stick with this download here, libemgu CV Windows x86 2.4.0.1717 exe. And go ahead and download that and save it. And once you've saved it, go ahead and run it and choose all the default options to complete the install. So before we go any further, now that we've installed C# 2010 Express and Emgu CV 2.4.0, I should probably bring something to your attention here. If we go back to the Emgu page, and then we go back to download and installation, there's a section here on troubleshooting the installation. Specifically, if you get a certain error, the type initializer for emgu.cv.invoke threw an exception. If you get this error at runtime, come back and follow the instructions on this page. Especially, probably the first thing you should do is download this MSVCRT 9.01 Service Pack 1 redistributable and then retest. And what this is it's a redistributable portion of Microsoft Visual C++ 2008. It's not the entire Microsoft Visual C++ 2008 download at all. It's a very small download. This is directly from the Microsoft site, so it's perfectly safe. And the reason for this is that some parts of Emgu CV were written and compiled in Microsoft Visual C++ 2008 and therefore require this, even if you're using 2010 now. Alrighty, so now our downloads and installs are done, and now we're going to add to our path variable. So if you stuck to the default installation directory, your install is going to be on the C drive, and then Emgu Windows x86 2.4.0.1717. And then what we're going to add to the path variable is going to be bin and then x86. So we can simply click up here, Control C to copy that. And then if you're using Windows 7, start Control Panel, System, Advanced System Settings, Environment Variables, and in the System Variables section, so it applies to all users, go to Path, and then Edit. Scroll to the end, add a semicolon, and then Control V to paste the directory that we just copied a moment ago. And OK, OK, and OK. And it would be a good idea after all those installs and modifying the path variable to go ahead and reboot. Alrighty, so now we modified our path variable and rebooted, and we're ready to start Visual C#. So we're going to go to File. Before we get started here, I should probably mention under Tools and Settings, make sure you have Expert Settings chosen, otherwise it's going to hide a lot of the menu features from you that you're going to need to access. So we're going to go to File, New Project, and Windows Forms Application, and let's call it CS for C#, Tracker 6, sounds good, and then OK. One other thing I should mention before we get too much further is it's a good idea to go to Tools and then Options. And by default, Show All Settings. This is unchecked and it hides a lot of the settings from you that way. It's a good idea to check this so they all appear. For example, the Windows Forms Designer choice does not appear with this not checked, and that has a lot of handy features to it. For example, the layout settings, you can choose to enable the grid and snap to grid feature, and having the grid on your form makes it easier to place components. Alrighty, now there's 3 steps that we're going to do to configure both our C# program and the C# environment for our Emgu install. And the first one is we're going to go to Project and then Add Reference. I should mention that this project menu is context sensitive. In other words, the options you have chosen on the Solution Explorer here on the left, for example, if you have the solution versus one of the parts of the solution chosen, the full project menu might not appear, so you definitely want to choose your project. And then go to Project and Add Reference. And then when the window comes up here, we're going to go to Browse, and then we're going to navigate back to our Emgu install again. So that's going to be C Emgu, x86 Emgu, and then we're going to go to the bin folder. And you'll notice that there's 9 DLLs here that start Emgu and end in DLL. Depending on if you're using Visual Studio 2008 or 2010, you're going to choose one of these and then the other 7. So you're going to choose 8 total of the 9. So since we're using 2010 in this example, we'll choose these 8 and then OK. And it's going to take a moment to add those references. Now that we've added the references, you can see they appear under References here on the left, and the next thing we're going to do is add some existing items. So now we're going to go back to Project, and then Add Existing Item. And now we're going to navigate to the Emgu install again, but this time into the bin directory. So Emgu Windows x86, bin, and x86, there we go. And so now we're going to, you see at the moment nothing appears here, that's okay. Go down to the bottom right here and choose to show executable files. Now we get all the files that are in this directory. And what we're going to do is we're going to choose all the files that start OpenCV _ and end in DLL. So from here down to here, all those. And again, it's going to take a moment to add those. And the next thing that we're going to do is we're going to highlight those 17 existing items that we just added, and then we're going to go to Properties, and we're going to change under Copy to Output Directory, we're going to change that to Copy Always. And let's go ahead and save before we go any further. Tracker 6, create directory for solution, that's good, go ahead and save it. And the final step that we're going to do is we're going to customize our C# environment by adding the special Emgu controls to the toolbox that we're going to add to our form eventually. So let's bring up the toolbox here. And what we're going to do is add these 4 special controls here, especially the image box control. You're going to use this on probably every Emgu C# program you ever do. So at first, when you start C#, these controls will not appear here. So I'm going to right-click on my toolbox and go to Reset Toolbox. Yes, we're sure we want to reset. And give it just a moment here. And so this is probably what your toolbox will look like when you start C#. So in the All Windows Forms, there's this control down here, Picture Box. You don't want to use this. You have to do a whole bunch of conversions of the images from OpenCV to be able to draw them in this Microsoft Control Picture Box. Rather, what we're going to do is we're going to add the Emgu specific controls, and here's how we're going to do that. So expand the general area if you haven't already, and then right click there and go to Choose Items. And when it comes up, we're going to go to Browse in a moment, but first let's take a look at our list of controls here. And we're going to see if we look for image box, image button, image list, no image box though. So we're going to go to Browse, and then we're going to browse back to our Emgu install again. And then the bin directory. And what we're going to do is we're going to double click on this file here, emgu.cv.ui .dll. And now if we look for image box, sure enough it's there. Usually it checks it by default. If it doesn't, make sure you check by image box and then press OK. And there's our 4 fancy controls, and we're going to move image box to the top here, and then the general section to the very top, since those are very commonly going to be used. And let's re-expand all the Windows forms, and now our toolbox is all set. Alrighty, so now we're ready to start placing components on our form. So we're going to use 2 image boxes, and we're going to try to be as consistent as possible with the previous tutorials. And we'll resize those in a moment. We're also going to put a button on there, and that'll be a pause or resume button just like the previous video, and also a text box. Alright, so let's bring the properties window back up, and let's go ahead and name our controls first. So to be, we'll abbreviate image box IB, and to be consistent with the previous tutorials, we'll call the first one IB original, and we'll call the second image box IB processed, and we'll call the button BTN pause or resume, and we'll call the text box TXT XY radius. Let's go ahead and set some properties here for the 2 image boxes. We have to set the sizes individually. We'll set those to 640 by 480. And now we'll set some properties for the button and the text box. So let's make the button text. By default, the video is going to be playing to start, so we'll change it to the option of pausing. And let's make the font a little bigger so we don't have to squint. Let's go with 12 on that. And then for the text box, we have a few more properties to set. Let's set the font to 10 so we don't have to squint, and it's best to pick a fixed width font because we'd like our numbers to display with the columns lining up when we're looking at the X and Y coordinates in the radius. So let's choose a fixed width font. Courier New is a good choice. And then we're going to need the text box, of course, to expand to multiple lines as multiple lines of data fill in. So we're going to choose multi-line to be true. And now we can resize it. And read-only we're also going to set to true, since this will be ideal. It'll allow it's going to grade out, and it's going to let the user highlight text that's in here if the user wanted to copy and paste it into something else to save it for later, but at the same time the user won't be able to edit the contents. And then for scroll bars, we're going to change that to vertical. And let's go ahead and do a final resizing here. And the last thing we're going to do on our form here is we're going to double-click the form to have the environment write the form unload for us, or at least part of it. And then we're going to double-click the pause button to have the environment start to write the pause button click for us. Alright, now we're ready to start coding. So we're going to start with our using statements. So we're going to be using Emgu CV, Emgu CV, CV enum, Emgu CV structure, and Emgu CV user interface. Now we're going to add some member variables, and again, these are going to be very, very similar to the previous programs. Capture object, and we'll initialize that to null. And we're going to have a Boolean variable. This is going to be a little different than the previous programs. We're going to call this capturing in process. We'll initialize that to false. And that might not be especially clear at the moment, but we'll get to that shortly. Now we're going to have our two image variables. If you're new to C#, the syntax to these might look a little strange at first, but you'll get used to it with some practice. So we're going to say image and then bracket BGR. So within Emgu CV, we still stick to the BGR color order rather than RGB, just as with OpenCV. And byte, of course, specifies an 8-bit color depth for each of the blue, green, and red portions of each pixel. And we'll call that image original. And we'll be able to display these Emgu CV image objects directly on the image box controls that we've already added to our form. No conversion will be necessary as in the previous program. And now we're going to declare the processed image, and that's of course a grayscale image. Also 8-bit depth. And now we're ready to move on to form load. We can skip right on by the constructor and start writing the form load. And here's how we're going to get the webcam. We're going to use the try catch block. And again, if you're new to C#, this might seem a little strange, but you'll get used to it with some practice. So try cap webcam is assigned new capture. And let's comment as we go here. Associate capture object to the default webcam. And then we're going to have a catch block. And for that, we have to make the parameter a no reference exception. And we'll simply call that accept. Catch error if unsuccessful. And we'll simply show, as with the previous program in Qt, we'll show that on the text box. So text xyradius.text is assigned, and we can use a property of the exception object here. Exception object.message. Show error object message in text box. And then of course we have to return, otherwise the program will crash if we allow it to continue there. So if we get this far, then we know we have a good capture object. Then we're going to add a line here, and again, this is going to look a little strange if you're not used to C#. We're going to call application.idle, and then we're going to increment that by, and this is a function we're going to write later, so it's going to be underlined red for now, but that's okay. Process, frame, and update GUI to be consistent with the previous program. And what this line is going to do is it's going to add the process image function to the application's list of tasks. So let me explain that a little bit. So the application.idle property here, what happens is the application has a list of sort of errands it has to run. Resize the form, if the user chose to resize the form, handle button press events, all that sort of thing, and then it has to bounce control back and forth to the operating system. So when the application has control of the processor, it shoots down its list of errands and then gives control back to the operating system and back. So what we're doing here with this application.idle and then increment is we're adding our function here that we're going to write a little bit later, process frame and update GUI. We're adding that to the application's list of errands. And then when we want to remove that from the list of errands, we're simply going to use the minus equals operator instead of plus equals operator to remove it. We'll see that later on when we get to the pause button. So in the previous project, we used the timer control. That would be one option here. And another option would be we could use multi-threading. But this one statement essentially achieves really what we need to. The application is going to give as much time as possible to processing the frame and updating the front end. And then it'll also be able to work in its other tasks and then bounce control back and forth to the operating system as need be. So this really is an ideal way to handle it, both in terms of the time sharing and also in terms of how easy it makes it for us to write the program. And one more thing we have to do in conjunction with that is we're going to update our member flag variable or state variable, call it what you prefer. Since capturing is now in process, we're going to change that to true. And then we'll comment that update member flag variable. And that's going to be it for form 1 load. So now we're going to write form 1 closed. This is going to be a very short function for us. So private void form 1 underscore form closed. And we have to pick certain parameters here for this function because it's in conjunction with the C# environment. So we're going to, even though we're not actually going to use these parameters in the function, that's okay. We're going to have object sender, and then form closed event args, and we'll simply call that E. Again, we're not going to use it, so it really doesn't matter. And we're going to say if cap webcam is not null, then we're going to call the dispose function for cap webcam, and that's it. Honestly, this function might not even be necessary. I think the operating system would probably handle that for us anyway, but it certainly doesn't hurt to put it in. And now we can move on to the longest function in the program, process frame and update GUI. And to make this a function that we can validly add and remove from the application.idle property, we have to choose these as the parameters, otherwise it won't work. The compiler would flag it, but that's okay. We can simply put those objects in there and not use them. Alrighty, so now we're ready to start our function. This is going to look very similar to the previous programs. There will be some syntax differences since we're now using Emgu CV, but the logic at least will flow the same. So we're going to have image original is going to be assigned cap webcam to get things started here. And query frame is the function that's going to get the next frame. And then we're going to have an error check line here so the program doesn't crash in case, say, somebody accidentally kicks the cord to the webcam and then it gets disconnected while the program's running. So we're going to do if image original is null, turn, and now our error handling is done and we're ready to start processing the images. Image original. So with this Emgu syntax, this is really nice. We don't even have to declare or initiate image process. We can simply return the result of image original dot in range, and that will go into image processed. And in range, since we don't have to pass in, you recall in the original program, in range took 4 parameters. We had to pass in the original image and the processed image as the first and last parameters, and the min and max filter values were the 2 in the middle. Here, since we're calling the function from the original image and we're returning the processed image, we're only going to need 2 parameters to pass into the function, and those are going to be new, and we can declare a new BGR object, and we'll search for the same red ball as in the previous video, so this is going to be 00175, and that's going to be the minimum filter value. And now the second parameter, the max color value. And now we're going to call the smooth Gaussian function. And here's how we're going to call smooth Gaussian. Once again, smooth Gaussian is going to return something just like in range did, so we can simply say image processed is assigned image processed dot smooth Gaussian. Whoops, don't want an underscore at the front of that. And if we pass in only one number here, it's the smooth Gaussian function is going to take that as both the x and y size of the filter window. Now the next function is going to be a little unique to Emgu in terms of the syntax. We're going to use the Emgu CV circle F class to store our circles in this program. And here's how we're going to declare that. We'll simply call the array of circles, we'll call that circles. And that's going to be assigned the result of image processed dot QCircles. And these parameters are going to look relatively similar to the previous programs. The order is a little different, but essentially the data that we're passing in is the same. So the first parameter will be new grade 100, and that's the canny threshold. And the second parameter is going to be new grade 50, and that's going to be the accumulator threshold. And the third parameter is going to be the accumulator resolution. Actually, the size of the image divided by this parameter is going to be the accumulator resolution. So we're going to use 2 for this parameter. And please consult the Emgu CV and OpenCV documentation as applicable for information on those 3 parameters. That'll give us a nice balance of at least detecting the ball but not over-detecting false objects in our image. And the 4th, 5th, and 6th parameters will be a little bit more straightforward here. So the 4th parameter is going to be image processed dot height divided by 4. And that's simply going to be the minimum distance pixels between the centers of the detected circles. And almost there for this function. We're going to pass in 10 here. That's going to be the minimum radius of the detected circles. And then 400 will be our last parameter. And then we're going to pass in the index 0. So the 400 is the max radius of the detected circles. And the index 0 specifies to get the circles from the first channel. And now we're ready to begin a for each loop. And the syntax of the for each statement is really essentially the same thing as, it's doing the same thing as a for loop, it's just a slightly more convenient way to do it, taking advantage of the fact that we can iterate through objects in C#. So we're going to type for each all being one word there that is a keyword in C#. Circle F, circle and circles. So as we step through the circles object, which is of type circle F declared up here, within the for loop, we can refer to each circle as we're iterating through it with this variable here, circle. So the first thing we're going to do is the output to the text box, and we're going to take advantage of some formatting functionality in C# to assist us with that. So first we're going to say if text xy radius dot text is not equal to a blank line, then we're going to add a new line. So txt xy radius dot append text environment dot new line. And let's explain the logic here a little bit. The idea is if we're not on the first line, in the text box, insert a new line character. So the idea here is the very first time a circle is detected, and then we're going to display the result. When we come in, the text box is going to be blank. So that first time through, this if statement is not going to execute, and we're not going to insert a new line character. Every time after that, when we get to this point, there'll be something in the text box already. So this statement here will evaluate to true, because in other words, it won't be empty. So then we're going to add a new line, and that's going to kick us down to the next line in the text box, so that way we're not writing on the same line over and over. That's really just a minor formatting detail. Now we're actually going to, in our next statement here, we're going to add the x, y, and radius positions to the text box. Here's how we're going to do that. So txt xy radius, and it's going to be assigned append text, ball position, x equals, and again this formatting is going to look a little similar to the previous video. The functions are slightly different in Qt versus in C# to achieve formatting in a text box, but it's really the same idea. So we're going to have circle.center .x .toString .pad left, and then we're going to pad it at 4 characters. So what that's going to do is, for example, let's say the pixel location, the x pixel location of the center of the circle is at pixel 5. We'd like it to pass into the box, the text box, 3 blank spaces and then the number 5. If it's 500, we'd like one blank space leading, and then 500. And this line is going to achieve that for us. So that's going to be the x position of the center point. Of the circle. And the next line is going to be pretty much the same thing, but for the y. Circle dot center dot y dot toString add left 4 y position of center point of circle. And now the last line is going to be a little bit more involved because the radius can be a floating point number. It's going to start out the same, circle dot radius dot toString. And here's what we're going to do. The pound character specifies if there's data, put the data there. If not, in conjunction with the pad character, specify a blank space. So we're going to put 3 pound characters, and then the decimal point, which is always going to put, and then the 0 character specifies if there's data there, put the data. If not, put a 0 character. And then pad left. And we'll pad that at 7. So the idea is we'd always like 3 spots before the decimal and 3 spots after. So for example, say the radius is 50. We would prefer that to display as blank space 50 decimal point 000. If it's 55.55, we would prefer that to display as blank space 55.550. And this line is going to achieve that for us. And let's neaten up our spacing a little bit here. And now we're going to have our last formatting line, in which we're simply going to drop the caret down to the very bottom of the, we're going to drop the scroll bar rather down to where the caret is currently located, which is going to be the line we just wrote, which is going to be the bottom of the text box. So that way we're always going to see the bottom of the text box, otherwise the scroll bar would stay at the top and the data is being written in wouldn't be scrolled down to. So that'll simply be text XY radius, scroll to caret. And now we can call our 2 functions to draw circles. The first of these is going to be a little bit tricky, but in a sense it's good that there isn't a function that directly does it in Emgu CV using the OpenCV 2 functions, because that's going to give us a chance here to look at how to call one of the OpenCV 1 functions from within Emgu. Even though it's not very often done, it's nice to know how to do it if you need to. So, same as in the previous programs, we're first going to draw a small green circle at the center of the detected object. Okay, so to do this, we're going to call the OpenCV CV1.x function. Okay, this is necessary because we're drawing a circle of radius 3. Even though the size of the detected circle is going to be much bigger. And the reason that this is kind of helpful to illustrate this is because the CV invoke object can be used to make OpenCV 1.x function calls. So here's how this statement's going to look. We're going to call CV.invoke. CV invoke dot. Now, if you look at the functions that are here, these are going to be the generally speaking, the OpenCV1 functions. These will look familiar. For example, CV in range S is here. You'll probably notice that from the very first tutorial. But in this case, what we're going to do is we're going to call CV circle. So first we're going to pass in image original. And the reason for that is because we're drawing on the original image. And then the second parameter is going to be the center point of the circle. And we can declare a new point object. And we have to cast these floats to ints. And now the next parameter is the whole reason we have to use this OpenCV1 function rather than the OpenCV2 function is because we need to pass in a 3 here. And that's not available in the OpenCV2 function, as you'll see momentarily when we draw the outline of the circle. So the 3 will be the radius of circle in pixels. And then we're going to pass in new MCV scalar. Now what this MCV is all about is, you probably recognize from the first tutorial, objects that start CV, for example CV scalar. MCV is managed, meaning within the .NET environment, managed CV scalar. So there's all these other managed equivalents to the OpenCV1 objects here that you can also use as need be for future projects. So managed CV scalar 02550, because we're going to be drawing in green. Now the next parameter is going to be -1, and that indicates the thickness of the circle in pixels. And -1 indicates to fill the circle. And now we're going to have the Emgu CV line type .cvaa. Might as well use anti-aliasing to make the circle look a little bit nicer. And then the last parameter is the shift, but we're not going to have a shift, so that'll simply be 0. And now we're ready to draw the circle around the outside, and that's going to be much easier. So here's how we're going to do that. We're simply going to call the draw function of the image object we have. So we can say image original.draw. And then we only need to pass in the circle variable in the array of circles that we're iterating through. And then a new BGR object. And we'll make that pure red. And then the thickness of the circle in pixels, we can specify as 3. And that's going to end the for each loop. And now to finish out the function, since we're going to be assigning the Emgu CV image types to the image box control, which is also the Emgu CV image type, we don't need any conversion here at all, so this is going to be as easy as could be. Simply going to have IB original image is assigned IMG original. And then we're going to have IB processed dot image is assigned IMG processed. And that's going to complete our process frame and update GUI function. And now we only have one function left in the program to write: button, pause, or resume click event, and this is going to be a relatively short function. So the first thing we're going to do is we're going to check if that member level variable or flag variable capturing in process, if that's true. So in other words, if we're currently processing an image, that would mean that the user just chose pause. So here's where we're going to remove the process frame and update GUI from the application.idle list of tasks. So we're simply going to put application.idle minus equals process frame and update GUI. Whoops. So we're going to remove the process image function from the applications list of tasks. Now we have to update our flag variable. We're no longer capturing in process. And we also have to change the button text to indicate resume so the user knows when they next press the button it's going to resume. And now we can say else. So in other words, else if we are not currently processing an image, that means the user must have just chosen resume. It should be chose, not choose. User just chose resume. So now we're going to add process frame and update GUI back to application.idle. Application.idle plus equals process frame and update GUI, and again, that's this line here is of course identical to back in the form 1 load event up here where we added it to begin with. And now we're going to update the flag variable. We'll now perform the capture process again. And update the button text as well. So the user knows next time I press the button that'll pause it. And that's the end of that function. And that ends our class. And our namespace. And I just realized I forgot a bracket here. And there we go. Now let's save our program and try compile. So we're going to go to rebuild solution. And hey, look at that. One succeeded on the first go. And now we're going to choose start without debugging. And here's our nice form. And there we go. It's working great for us. So I'll press pause. I'm still moving the ball at this point, but we can see it's pausing nicely. And there we go. And we'll try the pause one more time. And that's working great for us. Congratulations! You now know how to configure C# for use with OpenCV, and also how to write a basic object recognition and tracking program with a graphical .NET front end and making Emgu CV function calls. This video concludes the OpenCV install, configure, and basic object recognition and tracking program video tutorial series. For upcoming videos, I'm not really 100% sure yet, to be honest. Probably I'll do the USB motor controller example next. I know I've gotten a few requests for that. After that, I'm not really sure. Post in the comments if you have any particular area of interest. See everybody next time.